Well, that's
See,
great.
they forgot it's being recorded already.
Awesome.
Yeah, that's always an interesting dynamic in the scientific community because, you know, married scientists kind of rarely change their names, of course. So you never know who may be married to who. And as you get to know people, I mean, it's always incredible across the USGS every time I hear that, oh, you know, so-and-so is my spouse. Really? I had no idea. I know both of you, but I didn't know you were married to each other.
I'm still waiting to meet the person whose last name is River, who married a person named Flood. And so they could be River Flood, you know, so.
About how many people do you typically get with these sessions?
Depends on the month, like upwards of 50 or so sometimes, usually at least 20 or 30. It's hard though with depends on the time of year, and we always record them and share them on our YouTube channel. We see a lot of views after the fact as well, so.
That makes sense.
Yeah, we always find too that the recordings are what people usually look at.
It's so hard because there's so many competing webinars and meetings, and it's good and the good and bad about Zoom, right?
Yes, and sometimes meetings that start at 30 minutes after the hour are a little bit less attended, less well attended than those that start at the top, just because it's I don't know, we're not as used to joining things halfway through. But that's okay. Looks like we have a good crowd.
And what I'm going to do, Megan, just to let you know, is I'll share my PowerPoint slides, but then I'm going to dive into the live GeoCollaborate session, and I'm going to share the follower link so anybody can click on it and follow in real time.
Cool. Take it away. I will, at that time, take it away. I'll make sure to monitor the chat for you and just try to keep things moving.
Great.
Okay, that sounds great.
Maybe wait another 1 to 2 minutes, Sky.
Sure.
Sounds good.
This will be the third ESIP collaboration area meeting of the day. Just in case anybody's wondering, the biological data standards cluster met this morning. The marine data cluster just wrapped up, and actually the research object citation cluster is starting in 30 minutes. So it's a big day for ESIP.
That's awesome, Megan. You are amazing.
Yeah, the community is amazing. I just get to come along on the ride. All right, whenever you're ready, Sky.
Okay, sure, great, thank you. And thanks to everybody who's been able to join us today. I'm able to pop into these IT&I meetings every once in a while, but we thought this might be a good opportunity to dive into a piece of technology and a capability that was highlighted in the ESIP winter meeting. I was in a session there that Dave Jones here and a number of other people put together on SBIR, kind of small business investment opportunities that many of our kind of larger sister agencies are often able to take advantage of, who are part of those programs. And I saw maybe an opportunity for us to be thinking more about how USGS can come in at a point in those kinds of research projects where we could take advantage of a lot of the work that's already been done and the funding and the risk that's already been incurred by other agencies to pick up on some technologies or capabilities and methods and tools that are of interest to our work and useful in our mission, but that we may not be able to fund the sort of initial investment on to bring in. And that's kind of where this came up. So I met again with Dave Jones and Ellen Prager after that, and dove in a little bit to GeoCollaborate and saw some interesting potential for areas we have in USGS where we might be able to up our game a bit on how we tell our story with maps, how we collaborate together with our decision-making colleagues in different areas on things that we need to do in a geospatial context, in a mapping context. And so I asked Dave and Ellen to come and give us really more of a demo of this capability that has been developed through funding from NASA and from some others over the last number of years. And Dave will share a bit more about where their status is on that. And I see some really cool potential for how we might use this in press briefings, how we might use this in emergency response kind of work and other decision analysis work that we're involved in USGS. So I saw some potential there and wanted to get this out for folks in our community to take a look at. I think Dave will also share some recent developments with NOAA on their use of this capability and what they're doing in that regard. So some of our colleagues here may be from NOAA, and you may find some of this of interest to you all as well. So thanks very much for coming, and thanks Dave and Ellen for joining us, and please take it away.
That sounds great, Sky. Thanks so much. And I was just looking at my PowerPoint and saying, oh, you know, other things within NOAA, the way we're using it. We'll certainly talk about it. I was going to see if I could slip in another slide or two, but you never want to edit a PowerPoint slide 30 seconds before you start going. So I also want to introduce Dr. Ellen Prager, who is Storm Center's chief scientist. But Ellen has a great and varied background as well. So Ellen, while I bring up the PowerPoint, how about you share a little bit about your background?
Oh, thanks, Dave. So some of you might recognize me. I actually worked with the USGS years ago in the Coastal Marine Program, and then I was at Reston working a little bit with communications and on a National Ocean Conference. But I'm a marine scientist by training, but over the years, I've had a lot of different jobs. I was the assistant dean at the Rosenstiel School. I was the chief scientist at the Aquarius Undersea Lab, but really discovered my passion is in communications. And so in addition to working with Dave at Storm Center, I write popular science and children's books. Sometimes you might see me on NBC or CNN trying to make science relevant and sometimes even entertaining for the general public. And I also have probably one of the best gigs is I am the science advisor for celebrity cruises in the Galapagos Islands, and I have to go there several times a year. So, but I love what Dave is doing with GeoCollaborate and saw it as a wonderful tool for not only collaborating among scientists and researchers, but really getting the data out to the public, to decision makers in a way they can understand. I particularly like the fact that you'll see there's a subject matter expert that sort of curates the database, the data that is shown, and it's put on an easy to use interface. And I think that's one of the things that makes GeoCollaborate so innovative and unique. And so with that, turn it back to Dave.
Oh, thanks, Ellen. I appreciate that. And yeah, it's always tough to head down to the Galapagos. Not that I know, I've been there once. So I'd like to, I'm sharing my screen and I want to dive into a few PowerPoints, and then I'd like to give everybody an experience of GeoCollaborate. So we're going to share a link in the chat that I have ready to go as soon as I finish with this part. So GeoCollaborate is a SBIR Phase 3 technology. For those of you not in the federal government that might be watching, SBIR is Small Business Innovation Research. And I'm going to dive into this first slide, which comes in a multiple of phases. You basically have to answer a grand challenge from a federal agency, and you need to be a small business under 500 employees and propose to invent a new technology that will address some of these grand challenges that the federal government has. Any federal agency with a research budget of 100 million or more must put 3.5, I think it's almost 4% of that research budget towards small business innovation. And then each line office within those agencies comes up with grand challenges that they need solved. Well, we answered a grand challenge in 2011 from NASA, and that was how can agencies better access and share their data across platforms? And so we submitted a proposal. We were funded. It was very competitive. 600 proposals were received. They only funded about 39. And you're thrown into a pool with people who might be answering other grand challenges that NASA has, like what kind of suits are people going to wear when we go to Mars? So it's not like you have one-on-one competition either. There's all sorts of ideas out there. We were funded under phase 1. We developed a prototype. After the government did a deep dive on the technology from the prototype, they found that not only was the technology unique, it was profoundly valuable to the federal government. And so they immediately funded us for phase 2, where we developed the technology over the course of 2 years. And then we were funded to extend the technology to all mobile devices under what's known as phase 2E for extended. Then we were issued a phase 3 contract by NOAA. And as soon as an agency issues a phase 3 contract, that places you in a very unique position, whereas any agency can contract with you on a sole source basis to put that technology to work, to integrate it into other technologies they might have, or to expand research that they're doing. As long as those contracts have to do with data sharing and collaboration, they can be issued on a sole source basis by any agency. It doesn't have to be an SBIR type of agency with that research budget. As a matter of fact, a phase 3 contract cannot use SBIR funding. They have to use other funding outside of SBIR to put you to work. Because we have phase 3 status, we have also received a couple of other or additional contracts. We have 4 with NOAA. We have 1 with DHS, Cybersecurity and Infrastructure Security Agency, and also the U.S. Census Bureau. And the private sector is also using GeoCollaborate, the All Hazards Consortium that we work very closely with. They have 45,000 members, and they have members ranging from state emergency management personnel to sectors such as energy and utilities, to food, fuel, transportation, communications, and medical supply industries, so they can transport those goods and services and respond to disasters. So we're excited about that, and we're really excited that NOAA is taking sort of an aggressive stance in making sure that all of NOAA line offices are aware of GeoCollaborate. They just put together these 2. I just did some screen grabs from 2 websites, the Technology Partnership Office, where they're highlighting GeoCollaborate as a SBIR phase 3 technology, and describing that federal agencies may procure the technology using sole source justification. So they put that information out there. We were honored to brief the NOAA administrator, Dr. Rick Spinrad. And ever since that briefing, I don't know, Ellen, maybe we've had 3 or 4, major briefings with senior level officials and councils at NOAA, so they can really spread the word about GeoCollaborate. So what I'd like to do is do a little animation for you here, just so you can understand the basics of GeoCollaborate. There are a lot of portals, hubs, and websites out there. I'm sure USGS has them. I know they have them. We've been to quite a few of them, which are all great. NOAA has 30 or more, where each one of those curators of that mapping environment want people to come into that website to move around the map and display data and all that sort of stuff. But what we found, and what really led to our proposal and the invention of GeoCollaborate, is that, there's not all the good data isn't just in one portal. There's good data in other portals as well. And people do that curation and trusted data offering from their individual locations. So what GeoCollaborate does is it pulls out that trusted data from those hubs and websites, wherever they are, and combines them in a collaborative common operating picture. We call it a CCOP, and that's what GeoCollaborate is on the right-hand side here. So when people just connect to a URL and they turn GeoCollaborate on, and we'll do this during this session here, then your map will zoom out to match my map as a leader. And then you will display any data sets that I want to share in that collaboration session. Then once the data is shared, it can be shared across any platform, whether it's tablets, whether it's laptops, whether it's phones, mobile, smartphones, and then everyone is following the leader in real time. So that way, you don't have to be in the same room to be on a collaborative common operating picture. You can be anywhere, like a roadside stop, and you can move and participate. If you were on vacation and something happened, you could connect and see what was going on by getting a briefing.
And Dave, let me just jump in here for just a minute,
Sure.
because one of the lessons we've learned is that people have invested a lot in these portals and hubs, and we know, folks there from the different agencies and private sector have done that. And GeoCollaborate doesn't replace those portals or hubs. What it actually does is it accelerates the use of the data. And in fact, because what you'll see is all the followers are directed to go to that portal or website, it actually increases the metrics of users of the portal. So we're not taking away from portals and hubs, we're actually enhancing their use. So we found it's always good to explain that in detail.
No, that's really very important. Thanks for that, Ellen. And we have done over the years, briefings in certain areas, and the GIS and geospatial folks kind of, put up the no, we have enough maps and we can do all that stuff. But what GeoCollaborate really brings to the table is the collaborative capability to connect everyone in that real time environment. And we'll go down and show that here shortly. So this is what the interface looks like. We spent a lot of time to make it very easy. You have a leader that logs in with credentials, and there's an on-off switch. When the leader turns the switch on, the collaboration session starts. And then any follower that joins by clicking on that URL, they just need to turn GeoCollaborate on in the upper left-hand corner, and then we're synced. And we have that collaboration session going between one collaborator or two collaborators or thousands of collaborators. This is all operating in the AWS cloud. It's scalable depending on how many people want to join. We haven't reached a limit. And what's really important to understand about GeoCollaborate is, and Ellen mentioned this earlier, the leader can be a subject matter expert that knows about the data they're going to share. And when they share it into that environment, into GeoCollaborate, they can explain and interpret that data for what it means. And so those people that are following can understand about that data. It's a lot different than just putting data out there on a portal and saying, oh, here it is, come get it. And then people download it and say, how do I use it? How do I understand it? GeoCollaborate is that sort of gap-filling technology that allows people to understand it as a subject matter expert. Maybe even the PI for that data is explaining it. And then the leadership can be handed off to another subject matter expert for them to add their data and combine it with yours. So you're building a story of how important this information is for decision-making. And so the other point that I want to make is in the smaller text here at the bottom is that, and we found this through several projects, is that many analysts who have to look for data to use. And as an example, I'll say, looking for ice jams on the rivers in Alaska using satellite imagery and other reports and things like that, spend 80% of their time actually looking for data, looking for reports, looking for all these things that they need to make their decisions to issue, hey, there's going to be an ice jam and there's going to be flooding in the town of Galena in Alaska, and we need to get a warning out there. So we really believe that GeoCollaborate can unlock a lot of that time from just looking for data to delivering it, and then they can use it to make a better product or put together a more extensive briefing or get that warning out faster. So when the collaboration session is done, there's a dashboard that remains, and that dashboard is handles or displays all of the data sets that were shared in the collaboration session. So if a leader turns a data set off, the data set can still remain in the dashboard for people who receive that briefing to zoom in, zoom out, move around that base map, and display the data sets that were shared. This really, it's almost like handing the baton off in a in an Olympic race, if you will, where you give that baton to somebody and now they have the dashboard. They can zoom in, zoom out. They can look and see what aspects of their area of interest are impacted and certainly be off to the races. Or use the dashboard to brief the media, to hold other types of briefings. If you had a big monitor over your shoulder or you had something where you wanted to display it, you could do that in a full screen mode so you could brief people on what's going on with a certain situation. And we're going to demonstrate that as well. So this is just an example of how GeoCollaborate was used. We are funded under the NOAA JPSS program, Joint Polar Satellite System program, to access more NOAA satellite data and introduce it into, let's say, non-traditional user environments. So not to other scientists within NOAA, we're talking about how can we use this data to really help people make decisions. This is an example. The red area that you see is a temporary flight restrictions that were issued by the FAA over the August complex wildfire in California. And so we were bringing that data set in from the FAA. The yellow boxes that you see are actually task orders that were issued by the California National Guard for imaging of facilities that they believe could have been destroyed in this wildfire. But in order to confirm that, they need aerial reconnaissance and aerial photography of this imagery. So the Civil Air Patrol, it's tough to see in the icon here, this is the airport they were stationed. They used GeoCollaborate to see when the smoke was going to be clearing. All of this bright stuff that you see is the HER smoke model, high resolution rapid refresh model from NOAA, which is now gone operational. And you're seeing a forecast 6 hours in advance. So the forecast is for the winds to shift, for the smoke to be blowing towards the east, and for these targets to be exposed. Well, the Civil Air Patrol saw this on GeoCollaborate and said, we are using this operationally, and we're going to swoop in and get these pictures here. They could only go down to about 12,500 feet because that's what the temporary flight restrictions from the FAA indicate with these boxes. But they were able to image and get that data back to the National Guard so they could start to do damage estimates and analysis. And so it was a very quick success. And we even got a great email from the captain for the Civil Air Patrol saying how timely and useful the data was. So that was pretty cool. We also have another project going on right now in the Indian River Lagoon. And Ellen, I was just wondering, maybe you could talk a little bit about this one.
Sure. We got a grant from Florida DEP, Department of Environmental Protection, in their Innovative Technologies program, which we were really thankful for, to work with the Indian River Lagoon National Estuary Program. And there we're showing how GeoCollaborate could be used to coordinate during harmful algal blooms, as well as look at emergency response, and also potentially create a public-facing dashboard during harmful algal blooms, because there's, just like we were explaining, there's a lot of data out there from different sources. And right now there's no way to combine them. And people really need that when they're responding to blooms. And in the image you see, it shows a session where we've got, you can see the Indian River Lagoon in the background map. You can also see from the South St. John's Water Management District. They use satellite imagery, combine it with sensors and modeling, and have created chlorophyll A data that you can see in the colors in the background. We've also got some reports about fish kills. There's a picture of a fish kill that could be put into a GeoCollaborate session. And we also have some, you can see there were little phone symbols. Those are fish kill reports to FWC, the Fish and Wildlife. And then the other thing we put in, and we were talking about this, is there are little boat ramp symbols, because in response, if there are fish kills, you have to coordinate where volunteers can go to dump their fish. So again, we just in fact did earlier today a webinar on how GeoCollaborate could be used to coordinate among all the agency people and folks working together during blooms to look at data and come up with a better response.
Yeah, that sounds great, Ellen, and we hope that you're getting some questions together for when we're finished here. The other thing that we're doing is talking with NOAA Sea Grant folks, because they're very interested. They conduct a lot of workshops in training people how they can access NOAA data for harmful algal blooms and other things, and they're very interested in using GeoCollaborate to engage their workshop participants even more. And when the workshop is over, even remain engaged, because they can just connect to the URL and start to talk about the data, which is pretty exciting. So this next example is the All Hazards Consortium, where we work very closely with. This is their dashboard, and this is just a screen grab, an example of a Hurricane Ida coming towards Louisiana, and then making its turn. But what you see displayed is not just weather information, including the real-time radar data and also storm reports that are being reported here in the area. There was a wind event coming through the mid-Atlantic at that same time. You also see states that have turned red. They've turned red because states have issued declarations of emergency and issued transportation waivers. And so when you click on those states, you can get the governor's declaration of emergency and this transportation waiver from the Department of Transportation. Why would we care about that? Well, the members of the All Hazards Consortium, particularly the utilities, whenever there's a big hurricane or storm that makes landfall, they go into a mode called mutual assistance. And so utilities from 10, 20, 30 states will offer up their workers. And that's why perhaps you've seen driving down 95 or any other highway after a disaster, hundreds of bucket trucks driving down the road. Well, they're not driving there because they want to go for a ride. They're driving there because they've been activated through mutual assistance and they're headed into a disaster area. But what else is really unique is that they have to pass through a lot of states to get into that disaster area. Well, guess what? Those utility crews need to have a waiver in order to leave their jurisdictions. So if they were ever in an accident or whatever, they have to, some states allow them to get through tolls without paying. So they're using GeoCollaborate to keep an eye on these declarations and waivers, as well as real-time weather and also other types of information that might be valuable to them as they respond. And so we're continuing to monitor situation with GeoCollaborate, but we've also integrated these little symbols. I don't have much more detail on this currently, but we have links through ESIP and others about operational readiness levels, ORLs. We developed those operational readiness levels with ESIP and also with the All Hazards Consortium. So users of science data can trust the data even if they're not trained in science. So these professional decision makers that may not have any science background at all need a way to look at data and trust it quickly so they can turn around and make a decision in 30 seconds. So we've developed these ORL numbers that are in the dashboard so that those data layers can be trusted very quickly. This is an example of GeoCollaborate with the JPSS Fire and Smoke Initiative, under which we have some funding. We're using the VIIRS sensor on the SUMI NPP and NOAA 20 satellites. And this product is called the Fire Temperature RGB product, which is downscaled to 375 meters to show the fire fronts. And you see the U.S. Forest Service fire perimeter that's updated at least every 24 hours. And then you see the satellite imagery showing the hot spots of the fire and where it's moving. And then also the smoke is blowing in this direction, indicating the wind direction. One other thing I wanted to point out in this particular image are these little squares, these orange squares. These are electric substations from Pennsylvania Gas and from Pacific Gas and Electric. And you can see where all these substations are located, some of which are in the burn scar area. So this gives the utilities very high confidence that where they need to go to work on those substations as soon as it's safe. And then we can, as Ellen indicated earlier, put in pictures. This is the town of Greenville, which is right here where this arrow is. where the fire moved through. And this was a picture of it as the fire was moving through. So these pictures can be integrated into GeoCollaborate as well. This is an example of the Marshall Fire in Colorado, in South Boulder County. And this is a Maxar 30 centimeter optical image showing those 80 to 90 mile an hour winds just blowing that smoke towards the east. And this is a hotspot right here and another hotspot here and other ones. So this is just to show that any type of satellite imagery could be brought in if it were staged and made available as a service. That's how GeoCollaborate works. So think of that. Think of GeoCollaborate as the collaboration coordinator for displaying disparate data sets, so we can give a full and meaningful picture to a decision maker, so they can really move forward with their decisions. This next image is one that I'm going to show you in real time. This is sort of like a simulation, if you will, of a hazards collaborative dashboard. We know that USGS has a hazards program, and there are so many things that happen, from earthquakes to volcanoes and floods and things like that, that USGS needs to get in there and brief on. This is just some data sets that we're going to dive in, combined with some VIIRS hotspots from NASA firms that are being pulled in also. But it just shows you this is disparate data access and collaboration. So what I'm going to do is I'm going to stop screen sharing my PowerPoint slides, and I'm going to start screen sharing my desktop. And so if you just bear with me for a second here, I'm going to bring up that desktop. And now what you should see, Ellen, if you could give me a thumbs up that you see the split screen. Great. Awesome. What you see is a split screen of GeoCollaborate. And I am going to put in the chat a link for the follower. But I don't want you to quite click on it yet. I want you to pay attention to me, because I know all of you data geeks out there are going to want to start clicking. I would do it too. But I want to show you what happens here. On the left-hand side, I am the leader. And so I've turned on some real-time USGS earthquake reports of any level. And on the right-hand side is the follower. So when you click on that link in the chat, this is the map that's going to load up. It's just going to be a bright map. It's a web map. You can zoom in and zoom out. But when you click the on-off switch right up here in the upper left-hand corner, then your map is going to zoom out to match my map. And so now what I'm going to just hit reload. Oops, sorry. Hit reload on that one. I'm just going to hit this because I see some other earthquakes that have come in on the follower. So I'm just logging in here, and I'm going to continue. And so now your map matches my map. So within GeoCollaborate, I now have control of your map. So if I zoom into Southern California area, then the map on the right is the follower. You're going to be following me in real time. And so the other thing I want to show is that you can change your base map as well. There's a little arrow on the left-hand side. You can deploy a menu and click base map. So this is the follower. If you click base map, then you can choose whatever you want. I'll choose a National Geographic base map down here just to be different, but you can choose whatever base map you want. So now, if I want to dive into this earthquake here in Southern California, you will follow me in real time, and I'll just leave this. I'll leave this split screen up here as a screen share just for a little bit. You can click on that symbol. You can click on that USGS report and see when it was, and the time, the location, and the depth. Okay, so what we're doing is we're diving into the service that USGS offers, and we're pulling it in to GeoCollaborate and sharing that throughout all the collaborators in real time. So I'm going to zoom out a little bit here, and I want to turn on, let's just say the volcanoes. So active volcanoes, I want to turn on. And so that's going to turn on the follower as well. Okay, so now we see all of these active volcanoes. You can click on any one of those volcanoes if you want. And I see that this data feed is from the Smithsonian Global Volcanism Program. And this is a service that they are offering. So any one of these is immediately clickable. Now, what I'd like to do is go out for an example. Let's just say we're going to simulate a little situational awareness activity here. And we're going to go out to Hawaii and see what's happening, because there's always great stuff happening in Hawaii. And I'll zoom in here. So not only do we have some earthquake activity, but you can see the active volcanoes as well. And so we can do things in GeoCollaborate like issue geospatial messages. So I just put together, before we connected, a geospatial message, and I've displayed it in green, and my base map is the National Geographic. I'm just going to change my base map here so it's different and you can see it okay. I'll just make it a terrain image. So you see this triangle here. Well, this is a geospatial message, and you can click on that geospatial message by just clicking on the triangle, and then you can see a window pop up that is the latest update from USGS for the volcano. As a matter of fact, so you see current level, alert level, watch, and color code orange. We can format this up. I did this pretty quickly. And then there's also a link in here that you can click on, and that link takes you to the live webcam pointing right to the volcano. So I think you can see what's happening here, and that is that we're leveraging the data services that are being stood up by various agencies and organizations. And I want to show you one other thing as well, and that is we can turn on this thing called key points. Think of a key points window as a status or situational awareness for what's going on within the collaborative environment. I'm going to expand my leader here just to make it a little bigger on my screen share. And I'm going to turn on the key points window. So I'm going to turn it on. And what you should see here in the follower, I'll bring up my follower again, is the key points window showing up. Whoops. So let me just bring that back up. So now you see this key points window. It could be whenever the next briefing's coming up. It could be, hey, we're seeing something interesting here. It could be something else. So I just took the same advisory update from Kilauea, and you can see now that the watch is, and the color code for aviation is orange. But there's another thing in here that could be added, and this could be used in a real-time briefing environment. I'll show it here, but I'll also show it when I pull up the dashboard. There's a link here that says a media briefing slide. Well, what's that? This could be a slide that could be put together to immediately share with the media so they could send out on social media and all that sort of stuff that was produced. And here's that slide. So it's basically the same kind of text, but it's a little bit better for television. And so this can be produced and inset into GeoCollaborate wherever you'd like. And so this is an example of doing an on-the-fly media briefing as we're looking at this type of data. Now, what I'd like to do here is I'm going to pull up my leader instance. I'm going to zoom out just a little, and I want to show you some other data that we can pull in. Let's say this volcano, as it has been, is erupting, and it's spewing some gases. What we might want is we might want to have a look at air quality sensors. So I can turn on the EPA Air Now air quality sensors. There aren't a ton around Kilauea, but there is one, and that should show up on your device as well. You can click on it, I can click on it, and we can see that the PM 2.5 is 17, which is good, at least in that location. But maybe the winds aren't blowing in the direction of that sensor, and it's just getting fresh air from off the coast. So I can dive into the National Weather Service data and perhaps turn on a, let's say, a 6-hour wind forecast. So here's what happened. I just accessed the National Weather Service's NDFD, National Digital Forecast Database, and pulled out their latest 6-hour forecast of wind in this area. So now we have the volcano, and sure enough, look at that. The wind directions aren't conducive to having this air quality sensor pick up any of the gases that are being emitted. And it's a PM 2.5 sensor anyway, so it probably wouldn't do a whole lot unless it was actually erupting. And of course, here's the USGS latest earthquake report as well. Now, if I go over to my follower, instance is also displaying the winds that were shared. If you try to move your follower map around, it will bounce back to my view because we're involved in an active collaboration session. So I'm going to take a little bit of a pause here. So if anybody has any questions, please feel free to ask, because what I'm going to do is load up the dashboard and then talk to you about how the dashboard could be used in a media briefing environment. But I do just want to, yeah.
Before you do that, you want to show the debris, the potential for the debris flow data set? Because that's really from the USGS. That's a really cool data set.
Sure. Yeah, no, thanks for reminding me about that one. I'm going to turn off the wind forecast information. We're going to go back over to the mainland. And you can see all the other Air Now sensors in Hawaii, those green dots there.
Yeah, and if anybody's having trouble, if the data sets aren't loading on their phone, if they're following and it's not loading, try refreshing your browser. Sometimes if you get a little bit of an internet hit, it will interrupt it, but it will come back right to where we are, and you'll be able to see all of the data sets.
Yeah, thanks, Ellen. I'm going to see all the Air Now sensors showing up. I'm going to turn those off. But what I do want to do is turn on a data set of historical, I think, let's see if it'll be in here, from University of Idaho. I'm going to turn on the historical, or Idaho State. I'm sorry, Idaho State. You're not University of Idaho. I know that. I'm turning on a database of historical burn scars, and you'll see those starting to populate. This is some great work done from Idaho State of historical burn scars. And I'm just going to zoom in here. And then I'm going to turn on from the USGS a debris flow probability. I love this product. It's produced very quickly in debris in burn scar areas. And I'll just zoom in a little bit more to see if it starts to show up. Here we go. It's starting to come up here. Now, this historical debris burn scar database does not include last year. So you're going to see some of this USGS debris flow probability data show up where there may not be a burn scar currently, because it happened, the fire happened this past summer. So as we zoom right in to this area, all of a sudden we see these different colors. Well, what do they mean? Well, if I click on this orange, this basically means it's the Caldor fire, and it shows a moderate chance of debris flow. Moderate chance of debris flow if a certain amount of rain, I think it's a 1/4 inch of rain, falls within a 1 to 3 hour period. If the person who invented this is online and wants to correct me, please feel free. The red here shows a high likelihood of debris flows if a certain rainfall threshold is met. Well, this is really important when it comes to being near populations. And when this happens, we can also bring in, I'm not sure I have it in this instance, actually. I have that, well, I do have the real-time weather radar data, so we can see where it is raining at this time, along with the debris flow probability. But also within the Weather Service is the QPF, and I don't have that in here currently. But I could just load that in, which is the quantitative precipitation forecast, showing how much rain is forecast in this area for where these this debris flow probability is being issued. So yeah, thanks, Ellen, for reminding me to do that. And if I go back over to the dashboard that I loaded and reload the dashboard, look at where the dashboard ends up. It ends up right where the leader was with these data sets loaded that I have loaded for this demonstration. So the last thing I think I want to show that we will cover is basically how this could be used as a media briefing tool. So here's GeoCollaborate. I'm on the dashboard side, and the dashboard is simply this address. If you can see it, please feel free to type it in. Otherwise, I'll put it here in the chat. Here's the dashboard. Feel free to click on that and you'll see the same thing that I'm seeing. We can actively click on things in the key points window, but we can also go.
Hey, Dave, you've stopped screen sharing.
Oh, I did. Oh, sorry about that. Sorry. I can pull that back up. Stand by. Here we go. Okay, so this is just the dashboard. And if you clicked on that link, you can click on it as well. But if I were to give a briefing, one of the things I could do here is go to briefing mode or full screen mode, and you'll see how the map fills the entire screen. We have a legend, but we can close that if we want to. And now look at what we have. We can also move the key points window somewhere else if we want to, and put that off to the side. But now we have a real-time interactive dashboard where we can click and inquire on certain pieces of data and pull that up for the media to see. In addition, if the media had access, think of a local television station having access to this dashboard, they could put it in full screen mode, and then they could start to explain it in the chroma key. If it were a local broadcast meteorologist, they could explain what's going on, showing the history of the burn scars, showing the USGS debris flow probability product, and showing where it's raining right now. So anybody living in this area, as a matter of fact, I can do one other function outside of the dashboard, and that is create an area in a freehand polygon. And let's just say, oh, here's a burn scar and a lot of rain falling. So I'm just going to click that and tell you what's happening here. I created a polygon around this potential disaster area because of debris flows and burn scars. And the system went off to the Socioeconomic Data Applications Center at Columbia University in real time and just brought back the population. And not only the population for 2020, but in 2000, 2005, 10, 15, and 2020. So you can get an idea for how many people likely live in this area that I drew this circle. Now, it's a pretty large area. We could dive in right on Chico or somewhere else and do it in a town, and it'll bring back smaller numbers. But what we wanted to show here is how we could do cross-federal agency data access and sharing in a real-time collaborative environment. Now, if that doesn't get you excited, I'm not sure what will, particularly if your data really concerned with how you can put more data to work. This is something that's collaborative. Now, while I did this on the dashboard, every dashboard user can do that on their own. If I did this as a leader, then the results like this would be shared across everyone's system in real time. And to get rid of it, you just have to click clear. And I'll just demonstrate that real quickly on the leaders instance here by going to my Freehand Polygon, drawing, let's just say this area where there's a volcano and rain and some burn scars. So it's going off to NASA's CDAC, defining that polygon and pulling out of their population database the number of people that live there over all those years. So think about the opportunities and the other type of demographics that we could put in here. Underserved communities, who has transportation and who doesn't, who might need a ride, you know, other live type of services that could be brought in. And now as the follower, let me just pull up my follower here and make that full screen. Yep, there's the polygon. I'll move the key points here. And it's tough. I should change my base map.
So Dave, while you're wrapping things up here, let me just reiterate a couple of things that people always ask us. The data is not being downloaded. It is being retrieved directly from the trusted source, whether that's NOAA, USGS, CDAC, whoever it is. So we are not taking the data, modifying it in any way. And this is, I know, really important for if you're going to talk to the media or put your data out there. It can't be modified once the leader has brought it in. And it could give the opportunity because people know where to go to get information about Kilauea. You know, I always see all these reports about Yellowstone is about to erupt because there's been an earthquake swarm. Well, you could have an updated message. You could have the earthquakes and you could have a geospatial message about what's actually going on and anytime something happens. So like Dave said, there's a lot, we think there's a lot of uses for hazards in general.
Yeah. So we're going to take a pause here because I need a drink of water first, and we'd love to hear any questions that you guys might have. So thanks so much.
Thank you very much, Dave and Ellen. We've had quite a crowd following you this whole time, so we'll give them a moment. If you'd like to ask a question, feel free to raise your hand or pop it in the chat. You are able to unmute to ask a question.
I know what most people are doing. They're clicking around and moving. And that's what happens in the collaborative environment, which is fine.
I was doing that myself.
So I'll answer another question we get a lot. You don't have to download any software to be a leader. So Dave, maybe you could say something about that while we're waiting for any questions.
Sure. Yeah. And I'm just turning off the weather radar data here as the leader. Basically, the way that GeoCollaborate works, you can think of it as a collaboration via Twitter almost. This is all running in AWS. The leader identifies trusted data sources that they want to load into GeoCollaborate, into that instance. And as soon as they turn it on, your system is basically being instructed to go and get that data from that trusted source. So Storm Center doesn't download and save the data. We don't reserve the data. We're simply a collaborative environment that can pull disparate data sets together and then instruct all the followers to go get that same data. So we really think that it's revolutionary in a couple of ways. First of all, it's never existed before, so it is unique in that way. But from a data perspective, if you are offering data or curating data, GeoCollaborate is a great way to let people know about the data that you have and how you're curating it and how it's a trusted data set. And then they may go to your website to look at it and turn on other data layers that you might be offering. But the real benefit is accessing your data in combination with other agency data, whether it's state, federal, local, private sector data sets, non-NGO data sets that could really add to the overall situational awareness and decision-making for many, many people around the country.
Looks like Sky has a question.
Yeah, thanks. So yeah, just a couple of kind of two questions related to that subject matter expert leader role. You mentioned earlier being able to say hand off from one leader to another. And so I'm a little bit curious about sort of how that process works, if there are limitations on the number of leaders that can be working in a space, and sort of as a leader, once something's getting started, you know, especially with particular kind of briefing, maybe with certain types of decision analysis work, I can imagine needing to add some things in, add some data sources in sort of real quickly, real time while things are going on. Is that a capability that leaders have? Can we on the fly add another service and go pull some other data into the system right off during while something's going on?
Great question, Sky. Thanks for that. And the answer is yes and yes. You can hand the leadership off to someone else. There's only one leader at a time through this process. We started developing this in 2010, and we tried all sorts of opportunities for people to take leadership at the same time, and it's not pretty. You know, it's many people want to take control of the map, and you see tug of wars going on and all that sort of stuff. So one leader at a time, fully tested. And when someone logs in, they take the lead from the other person, and it says so-and-so has logged you out as a leader, and they have lead. So what we recommend is when a collaboration session is going on, you also have a telecon going on at the same time, or you have a Zoom session or something like that, so you can at least get the voice across. Keep in mind that when we developed GeoCollaborate, it had to be a new invention. So we stayed away from integrating chat. We stayed away from integrating video and all that sort of stuff, because there are so many other products out there that you can do that, and you can launch in parallel to what you're doing with GeoCollaborate. So we wanted to be very, very careful that everything we did within GeoCollaborate was unique and met the rules of SBIR, so we could eventually get to that phase 3 status. The other question you had, and I'm assuming you can still see my screen, right? Do you see my menu still popping out? Okay,
yeah,
great. So there's an add layer to cache menu here, and I'm clicking on that. And so there are layer types that you can add. So there are all sorts of layer types in here, from dynamic to WMS to KMLs, Atom RSS feeds, or GeoJSON, CSV, feature services, Real Earth. If you're not aware of Real Earth, that's from University of Wisconsin. They have a big contract to download and save a lot of NOAA's satellite data. So they developed the ability to not only collect and ingest and process that data on their supercomputers, but they're processing web map tiles of that satellite data as well. So Real Earth is basically web map tiles. We have it as a separate item here because they have a lot of great satellite imagery. We can even get Japanese Himawari satellite data. And Real Earth, we built a data search engine into their supercomputer. So when you go, if I click Real Earth and then I click search, and then I just click a keyword like GOES and have it go in and do a search on the GOES data, then it will come back with all of their GOES data. This is global lightning mapper stuff, GLM total energy, this. Yeah.
Hate to interrupt you here, but I think you made it, you've showed the point. Yeah. Yes, the answer is yes, but I think there's at least another question there that we want to get to.
Okay, let me answer one more thing from Sky, and that is you can do it on the fly. So if you had that service address, you would just throw it in there and it would share with everybody right away.
Awesome, Doug.
Sorry.
Yeah, my question is, how persistent is the data after the briefing session is over?
Yes.
So you show these the press this wonderful briefing, and then the session's over. can they come back to the same website with the same layers presented in the same way to get the same data to follow up on questions themselves?
Yes, so that's a great question, Doug. Thanks for it. The data will remain all up on the dashboard as long as the leader wants the data to remain. So I could leave as a leader right now and shut down all my web browsers, but you will still have the data that I left on when I left the session. So when you're in a GeoCollaborate environment, it's important to know that as a leader, you are in control of whatever data sets will display on the follower and on the dashboard. So on the exciting side as well is if somebody's looking at a dashboard, the leader can change all of the data layers that display on the dashboard every day, 3 times a day, 5 times a day, however long you want it to update or be displayed to the user. But all that control is in the hands of the leader with credentials.
Yeah, and we should also say that if there's some data that people only want to show for a certain period of time, it can be turned on for that period of time and then turned off. So the data, again, as Dave said, it is persistent unless for some reason there might be something that you don't want everybody to see for an extended period of time, that could be turned off as well.
Right.
All right. Well, Dave and Ellen, I want to thank you again, and thank you, Sky, for inspiring this webinar today. Thanks everyone for attending. We look forward to seeing you again next month, Thursday, May 12th at 3 p.m. Eastern time, so 30 minutes earlier than today, when I believe we will have a USGS water data visualization and information dissemination IT&I tech dive. Is that enough words for you? Hope you'll join us then, and thank you again.
Great. Thanks, everybody. Thanks, Megan.
Thanks, everybody. I also just put our emails in the chat. If anybody wants to get a hold of us, we'd be happy to talk to them as well.